All right, guys, I hope you had a good vacation and you're back. So if you can, of course, it's much more interesting if you turn your cameras on, so please do so, unless you are in a situation where you can't. So go ahead, guys. And here is what we finished off last time. So we learned the trig formulas: cosine of difference of angles, sine of difference of angles, sine and cosine of the sum of those angles. And finally, we will apply those ideas. How do we find the derivative of trig functions? Remember, guys, that we had two formulas for the derivatives. We had the one with limit as h goes to 0, and one that we wrote this way. So here they are. So if I take the derivative of a function, I can write it as limit where z goes to x, f of z minus f of x divided by z minus x. Or the second formula, which is limit as h goes to 0, f of x plus h minus f of x divided by h. Those formulas are mathematically equivalent, logically equivalent, but not psychologically equivalent. And the first formula we always prefer when we are trying to do the derivative for rational functions. But for exponential functions and for trig functions, the second formula is better. So let's try to see what happens if we try to calculate the derivative of sine x by definition. So the derivative of sine x is limit as h goes to 0 of sine x plus h minus sine x divided by h. Whereupon we can apply the sum of angles formula. So what is sine of x plus h? This is limit as h goes to 0 of sine x cosine h plus cosine x sine h minus sine x here, yes, divided by h. You see what I did, guys? So if I were to use the first formula, it will be a bit difficult to figure out what would be the next step. But here it's sine of x plus h, and I know a formula for sine of a sum of two angles. Here it is. I expanded sine of x plus h. Now I can group certain items here. So for instance, you can see that this part has a sine x, which would be not affected by the limit because we are taking h to 0. And we have this part, which is not affected. Similarly, we have this middle part. Good. We have this middle part, which we are able to write. We're able to write this as, hope you can remember this, guys. So we can write it as limit where h goes to 0. Look at that previous formula. So we can factor out sine, and then we get sine x. Here we have cosine h minus 1 divided by h plus the second part. What we can write is simply we can factor out cosine, and we see sine h over h. Good. So this is what happened to the red part, and this is what happened to the blue part. Now, guys, it's not only interesting to figure out what is a limit, but really what is the limit trying to express. what is this? And what is this? Okay, let's see if you remember, guys. Let's see if you understand this interpretation. What is each limit? What is it talking about? So if you were to see this limit, you would think, what was somebody trying to do? You understand my question? Guys, imagine I call you and you are in an Uber car. Yes? And I ask you what you are doing. You can say, I am sitting in such a way that my legs are at 90 degrees to my torso inside of a driving car. Yes? And the car is turning left, right, forwards. You can give me that type of technical description, but you can also tell me where are you going, right? So normally when I ask this question, you tell me, oh, I am driving in my Uber to Grand Central, correct? And why is it so useful? Because you know the destination. And if you know the destination, you can sometimes get there by a better route. Clear? So what is the destination here? What is the destination? What is this trying to figure out? What is this trying to figure out? Any ideas? Okay, Erin, derivative of cosine at 0, right? Not the h is not necessary. It's the derivative of cosine and sine at 0, and that is precisely what I was interested in. You understand, guys? I haven't yet solved anything, but there is something better than solving. 5 or 7, it's not doing much, but you here understand what is the destination. Look at it. We started trying to figure out the derivative of sine at an arbitrary point x. And we realized that we can do that if I know the derivative of sine and cosine at the particular point 0. You understand? We moved from arbitrary to a very definite point. It is exactly what happened when we took the derivative of e to the x. Do you remember? So let's look at it for a moment again, guys. Do you recognize the first limit? So we have limit as h goes to 0 of cosine h minus 1 divided by h. What is that? This is simply the limit as h goes to 0 of cosine of 0 plus h minus cosine of 0. You remember that cosine of 0 is 1 divided by h. Yes? And this is the derivative of cosine x, but at a specific point where x is equal to 0. And the second limit is the same idea. It's the derivative of sine at 0, guys. Very important to recognize such things. It's really, in this class, we're doing exactly the same thing. We're just, when the limit is difficult, it's really a certain derivative. Okay? And that is simply the derivative of sine, where x is 0. Any questions? You look very excited, all of you, I see, right? I guess the vacation did not, well, it was too short, correct? So now let's try to have initially a very intuitive explanation of what those limits might be. They are not easy limits. And let's try to see if we can have some intuition for what they might equal. So here is, guys, the unit circle. And what am I doing? I'm pushing the angle to 0. So where is my angle? My angle is the arc. This is the angle H. And if this is the angle H, then this part is my sine of H. It's just this vertical piece of rope. Yes? And then we have cosine right over here. This is my cosine of H. Now, before I say anything too much, guys, let's see if you, and it's of course a very loose question. Do you see what happens if H is going to 0? H is going to 0. The arc is getting smaller, the red segment is getting smaller. What do you imagine will be the ratio of sine H over H? And then, of course, I would be happy to hear an explanation. What do you imagine this ratio is going to look like? Okay, Alexandra, okay, you have one thing. Of course, there is no need for a question mark. It's a statement. But about the rest of you guys, think about it intuitively. Do you imagine what it might be? I just want to see what you would have here. 1 factorial is fine. And the rest of you guys? Nicole, Jamal. And of course, I would like to hear, why would you imagine that? Well, Moshe, yes, 4, very funny. Think about it, guys. What happens to this blue arc as H goes to 0, H is smaller, and what is the comparison of that blue arc to the red line segment? What would you imagine is happening?
So it's going to be 1 because as the arc is going down, sine H is going down as well. So it's equivalent, therefore it'll be 1, no?
Well, be careful, of course, right? So 1 over, when Sophia, you say 1 over 1. So you're, in other words, you're noting, notice, if you say the answer is 1, I think 2 people or so mentioned. Do you see that the numerator and denominator must be alike, right? How do you get 1? You get the number divided by itself. So it will be 1 if the blue arc and the red segment are going to approach the same length. Now, why would they approach the same length, guys? So you see, one way to see that is to imagine that the circle, in fact, the circle you're seeing is a polygon, yes? And if you were to watch a polygon, it's you can think that it's this side, right? So you can think this, there is a microscopic segment here, and that segment, if you were to zoom in here, the segment is perpendicular to the x-axis. Can you imagine that? If it's a polygon, it's made of tiny segments, and the segment next to the x-axis is essentially perpendicular to the x-axis. This is the situation, right? So basically, you can see that let me just ask, can you see it? Which, at any given moment, which is longer? Is H longer or is sine H longer, or are they the same? What do you think is the longer side? And I want many of you to answer, not just 3, not just 4, not just 7. Come on. I mean, H is just about, I'm asking which is longer. You're telling me it's H. I'm asking which of the, sorry. My apologies. You're saying H is longer. Good. Yes, you're saying H is longer. Good. You can see that it's curving, so it's intuitive that H is longer than sine H. Okay, so at least in the first quadrant, you can see that sine H is bigger than H. The absolute value of sine over the absolute value of H is going to be always smaller than 1. But as I make this H smaller, there is going to be less and less difference between sine H and H. We will later give a very rigorous explanation of that. It's just I'm trying to build your intuition. You see, guys, why would you see that this is, hopefully see that it is obvious. You don't have to accept this. So the circle, I think of it as a polygon made of many tiny line segments, and the line segment emanating from the x-axis, you see, it's like, it's made of, if you exaggerate, this is the polygon, right? It just has lots and lots of edges. And the edge emanating from the x-axis, this edge, is perpendicular to the x-axis, which means that sine and h, they become more of the same size, roughly speaking. Good. So we expect that this limit will be 1 if h is getting smaller. Good. And perhaps, let's see if we want to do that. It's not terribly necessary, but let's view the animation. Look at this particular situation, guys. Do you see? Here is, I mean, they didn't display the last digit, but you can see that here they are almost the same. If you make it very, very small, you can see that that here there is some difference. Theta, as the angle increases, becomes larger than sine. You can see that this blue arc is larger than this red line. But as you come closer, you can even imagine it. You see, as you come closer, you can see that this curve, if you zoom in at it, it will be perpendicular to the x-axis. And therefore, very close to the ground, very close to the x-axis, the red segment and the blue segment are going to be of the same length, essentially of the same length. Good? I hope you see that, guys. It's a bit more difficult to see what happens with cosine, but let's try. All right, so here we have another circle. Here is my angle H. Here is my sine. And here is my cosine. Good. So this is cosine h, this is sine h, okay? Now, what is this length? Would you tell me, please, what is this length? Type in the comments. To be precise, what is this length? Sorry, let me undo it. What is this length? This is what? Thank you, Jeffrey. Thank you, Alexandra. Come on, guys, only 2 people. 1 minus cosine, precisely. This is 1 minus cosine h. Right? Remember that we were interested in cosine h minus 1. It's very close to it, yes? So this is 1 minus cosine h. And then what is this arc? What is this length here? So this is a hypotenuse of a right triangle. You agree? And this blue curve, sorry, this pink curve, I presume it's pink. So this pink line segment is going to be eventually very similar to h. You agree, right? It's smaller than h, but in the limit, it will be very similar to h. Now, what do we see here? We see that this triangle, it's going to be essentially So, so basically you can see that in this right triangle, sine squared plus this number squared plus 1 minus cosine h squared is equal to the pink. But in the limit as h goes to 0, you can see that that the full length of the hypotenuse is matched by the leg, by sine h. Do you see that? In other words, if h is very small, in this triangle, essentially, the full length is carried by sine h, and therefore this part must be plus 0 squared, right? It's sine squared plus 0 squared must be equal to essentially h. That's, of course, very heuristic. We can make a very rigorous argument for that. I'm just hoping you can see why that indicates that this segment compared to h will have to go to 0. It's much, much smaller than h. Do you see that? You see how I'm reasoning, guys? It's that I'm saying that essentially we have that h is almost the same as sine h, right? But we also have that somehow like h squared is equal to sine squared h plus 1 minus cosine h squared, right? And since they are a match, that means that this number is vanishing to 0. Good? So we conclude heuristically still that the limit as h goes to 0 of 1 minus cosine h divided by h will be equal to 0. Are you with me? It's a bit harder than with the sine, but do you understand how I say that? If h is very small, you can imagine that h and sine are the same. So in that right triangle, the only way that's true, the only way in the right triangle, the sum of the squares of the legs is equal to the hypotenuse is that if one of those legs, namely 1 minus cosine h, is 0, essentially 0. So that means that compared to h, it will vanish. So this is then what we obtain. Let's go back to the situation, guys. Cosine h minus 1. Cosine h minus 1 is simply negative of that value, right? So that means that limit as h goes to 0 of cosine h minus 1 over h, which is just minus 1 minus cosine h over h, will have to go to 0 as well. So that means that we are seeing here a 0, and over here we are seeing a 1. Good? So that means that the derivative of sine the derivative of sine x, which was limit as h goes to 0 of sine x times cosine x, cosine h minus 1 over h plus cosine x sine h over h. What do we get here? We get that this is sine x times 0 plus cosine x multiplied by 1. In particular, the derivative of sine is equal to cosine x. Good? We just figured out that derivative of sine is cosine x. Now, I would like you to do the following, guys. See if you understood it. I'll give you 6 minutes. Try to tell me what is the derivative of cosine x from first principles. You can use this fact. You can see we already derived it, but cosine of alpha plus beta equals to cosine alpha cosine beta minus sine alpha sine beta. So tell me what's the derivative of cosine x. You have 6 minutes. Moshe, what we are trying to find, if I understood your question correctly, is the derivative of cosine. You don't have to type all of it in the comments, just type the result. I will believe you that you solved it with two eyes closed. Okay, Jamil, you have a small, tiny error. Okay, good. Safa, careful a little bit. All right, good, Cillian. All right, ready? So this is very simple, guys. Same idea. What's the derivative of cosine x? This is limit as h goes to 0 of cosine x plus h minus cosine x over h. And I can use the sum of angles formula for cosine. What does it do, guys? Cosine x, cosine h, minus sine x, sine h, minus cosine x, divided by h. Now I can group terms where I can factor out, let's say, cosine x, and terms where I can factor sine x, because cosine x and sine x are not influenced by the limit. H can do what it wants. So here you can see are the terms that contain cosine x. And here is the term containing sine x. So breaking it apart, what do we have? We have limit as h goes to 0. Do you see I can factor out cosine? So here we have cosine. Here we then have cosine h minus 1. Do you see cosine x? And here we divide by h. Minus, here we can factor out sine x. And we have sine h over h. Good. So that is what happened to the red part. And then this is what happened to the blue part. Now we already know those limits. Again, guys, to find the derivative of cosine at an arbitrary point x, we just need to find the derivative of cosine at 0 and of sine at 0. And intuitively, we think that the derivative of cosine at 0 is 0, and the derivative of sine at 0 is 1, because we think that sine h over h are nearly the same. Sine h and h are nearly the same. Notice h is in radians. We will ask questions about it later. So that is cosine x times 0 minus sine x times 1. And the result is simply minus sine x. Good? Now, knowing that, guys, here is what we have learned. We have learned that the derivative of sine x is cosine x. I would derive it on exams because I would always be worried that I don't remember it correctly. And the derivation is not too hard, guys. So 2, the derivative of cosine is minus sine x. Now, please help me figure out what is the derivative of tangent x. And one short hint is that you don't always have to go to the definition. Tangent is what in terms of, well, what can we do with tangent? How can we use the information obtained about sine and cosine to figure the derivative for tangent? Go ahead, guys, think about it. Exactly, quotient rule. Do you see what is tangent, guys? This is the same as what? As the derivative of what over what, please? I want many comments, not just one. I want what? I have here 29 people. So give me at least 15 comments. Six, 7, 8, 9, 10, 11. Come on. I'm missing 2 comments. Okay, let's see what we have there. Sine over cosine, sine over cosine. Wonderful. The derivative of sine x over cosine x. Go ahead, guys, you have 2 minutes to calculate it. Good, Safa. Okay, we have another tool. Come on, guys, you have 40 seconds. Good. Wonderful. Come on. Few more. All right, time's up. Let's do it together. Good. So we use quotient rule. Remember how quotient rule is applied. Square the denominator, copy the denominator, multiply by the derivative of numerator, which is also cosine, minus, now take the derivative of the denominator, which is minus sine x, multiplied by sine x. And what do we get? We get cosine squared x. Here we have cosine squared x plus sine squared x. Now, cosine squared plus sine squared, that's Pythagorean theorem, guys. The sum of the vertical part, the vertical leg of the right triangle squared plus the horizontal leg squared. And they add up to 1. So we get 1 over cosine squared, which is the same as secant squared x. That's the fashionable way of writing it. Now, help me, please, if you know the derivative of tangent, please tell me what is the derivative of secant x. Again, guys, 2 minutes. Okay, 2 people. Come on, guys, 1 more minute. Fast. We have 5, 6. Okay, good, Celine. Good, Claire. So the derivative of secant, guys, is the derivative of, good, Alexandra, is the derivative of 1 over cosine, right? If you have to remember any of the derivatives, remember the derivative of sine and cosine. The remaining ones are quickly derived, right? 2 minutes is just because you're doing it for the first time. You can do it in a few seconds, yes? So the derivative of 1 over cosine is, we haven't yet learned other techniques. You can even do that faster. But this is going to be quotient rule. So cosine squared x, we have here cosine x multiplied by derivative of 1, which is 0, minus derivative of cosine, which is minus sine x multiplied by 1. Good? Oh, everybody understood what I did here, right? I just applied quotient rule. And the way to remember quotient rule is you take the denominator squared, copy the denominator, multiply by derivative of numerator, subtract, and reverse. So what we have here is simply sine x over cosine squared x. And of course, we could leave it like this. It's nicer to make it more relatable to secant. So what we can do is we can say this is sine x over cosine x multiplied by 1 over cosine x, which is simply tangent x times secant x. And it's much nicer to say simply that the derivative of secant x is secant tangent. Easier to remember. Derivative of secant is secant tangent. Good? Now, guys, it's up to you to verify the following 3 identities. We will not do them now. We can, if you want, to talk about it after class in office hours. But the derivative of cotangent. Cotangent is a very similar function to tangent, so you expect the derivative to look alike. So the derivative of cotangent is going to be minus cosecant squared x. The derivative of cosecant x is going to be minus cosecant x cotangent x. And have I missed any functions? I don't remember, right? I think those are the ones that I missed. But there are 6 altogether. Now let's return to the notes and see what else is here. All right, guys. So now let's just do a little bit of practice. Please help me figure out the derivative of x squared tangent x. Go ahead. You have 2 minutes. Should be done in 1. Yes, Aaron, absolutely right. Yes, Alexandra. Grant, what about you? I haven't heard you. All right, guys, so how do we do this? It should take a few moments, right? So we have 2 functions and we know how to derive each of them separately. So we have this function, which I label as f, it's over x squared, and another function which I label as g, it's over tangent. So we see that the result should be g prime f prime f. Yes? This is the product rule formula. We have the traveling derivative. It starts at x squared, doesn't touch g, and moves all the way to g. So the derivative of x squared is 2x. Here we leave tangent alone. Here we say it's just x squared secant squared x. That's the derivative of tangent. Yes? Done. All right, what else is there? So let's take the derivative of secant over 1 plus x squared. Please calculate it fast. 2 minutes. Guys, I think I'm getting old and I'm losing vision. I see more and more screens are shut down. Right? What happened? Sandra, what happened? Sophia, Dorian, Jeffrey, Safa, Tre, Marine, Elmira. Well, good, you know, good medicine. I'm regaining eyesight a little bit. Brian, P, Tre, are you there? No worries, Sandra. Good. Good that you are here. Come on, guys, quickly. Good, Safa, you're fast. Come on, guys. I only received one answer. Thank you, John. Two answers. 3 answers. Well, I cannot blame you. This is annoying to type. So let's do it together, guys. So what do? We take the denominator, we square it. Then we copy the denominator. And then we just observe what's the derivative of secant. Easy to remember. Secant tangent. And subtract, and we take now the derivative of the denominator and multiply by the numerator. Good, that's it. Don't bother with it as we are not interested in this function. It's just an exercise to try to calculate derivative. Nothing more. Good? Now, of course, this one is a bit simple, guys. So the derivative of e to the x cosine x, you all see it's e to the x cosine x minus e to the x sine x. Yes, just apply product rule. Now, please take the derivative of x, e to the x tangent x. What's that? 2 minutes. Good. Alexandra, there should be 3 additions. I'm sorry, 2 additions, 2 plus signs. Think about it. It's a triple product. It's x, e to the x tangent x. Yeah. All right, Safa looks good. All right, guys, this one is easy, yes? Derivative of the first function and leave everything else. So it's the derivative of x here. Plus x e to the x, we took the derivative of e to the x, tangent x. Plus, we now just need to take the derivative of tangent, which is just x e to the x secant squared, and we have that. Good? All right. Let's do number 2. Derivative of 7x squared minus secant x plus secant x cosecant x. All right, so John, notice that that a lot of you began, so you have derivatives of this part is easy, and then you have a product rule here, but you don't necessarily have to apply it. So let's see what is secant over, well, no, I mean, in this case, yes, that's fine. That's fine, that's just an annoying question. So you see, what's the derivative of 7x squared minus secant plus secant cosecant, right? So the derivative of 7x squared is 14x minus secant x tangent x plus, here we can apply product rule, so derivative of secant is secant x tangent x cosecant x, and then the derivative of cosecant is minus cosecant, so we can write this as minus secant x cosecant x cotangent x. Don't worry about simplifying, as this question isn't interesting. Right? We don't use it for anything other than to try to find the derivative. Good? Just grind work. Good. One last question, guys. It's this annoying question. Cosine x times tangent x divided by e to the x plus 5x squared. That's right, it's separately. Is the question. Yeah, just find the derivative of this function and we move on. Right, guys, I'll see you in a minute. All right, guys, how has it been? So you can, of course, do it directly, but look at it, guys. There is a quotient rule and a product rule. And it's much easier to simplify it. What is tangent? It's sine over cosine. It would be much simpler before taking derivative to simplify the numerator and to just write that numerator is simply sine x. So it's sine x 5x squared plus e to the x, and we take the derivative of that, which is just a regular quotient rule. Otherwise, we would have, upon taking derivative of numerator, apply product rule. So we have 5x squared plus e to the x squared, 5x squared plus e to the x. Derivative of sine is cosine x, and minus 10x plus e to the x sine x. Yeah. All right, that's good. Let's move on. All right, guys, so here is the limits that we just learned. It's cosine h minus 1 over h, sine h over h. Now, there is not really an h there. I mean, what does it mean when I say limit as h goes to 0 of sine h divided by h equals 1? All I'm saying is this. I'm saying that if the angle inside of sine is vanishing and we divide by same angle, we are going to get the ratio 1. Notice in my argument, I did not speak of any letters. It just, and if you understand this, guys, tell me please, what do you think is the limit as h goes to 0 of sine of 5h divided by h? Okay, Safa. What about the rest of you guys? Come on, think about it. Okay. We have a few people. Now, do you see why the answer is, it's correct, the answer is 5. This is what you're observing, guys. You should have this pattern. So sine of a small angle divided by a small angle is nearly 1. That's what the limit is doing. The limit is making the angle get ever so small. So here, what is my box? My box is what I have inside of sine. This is my box. Now, the denominator box is not complete. Do you see what it's missing? It must be the same thing inside of sine as you have in the numerator, in the denominator. So you just place a 5 here. Now the answer is 1, but you cannot just place something that was not there. You have to balance the formula, so you multiply by 5. You see, this is now 5 multiplied by something that vanishes to 1. Clear? And the answer is simply 1. Now, tell me if you understand what is the limit as h goes to 0 of let's say, sine of 6h divided by 3h, please. Okay, good and fast. The answer is indeed 2. Now, why is the answer 2? We will learn it more and more, guys. For now, just let's do it in the same box method. So here is where we have the box. Now we can move the 3. Let me move the 3. And place a 6 here. The 6 was not there. Right? So now this is now 1. Now there is a 3 that was moved. Here it is. And I have to cancel the 6. So here it's the cancellation of the 6, yes? So what I am left with is 6/3 sine 6h divided by 6h. And that limit is simply 6/3 times 1, which is, as you said, 2. It's equal to 2. Just to be sure, tell me, please, what is the limit as h goes to 0 of sine of h squared divided by h? What's happening now? Well, there is no h, guys. When you say h, h is a fiction. It's just a letter. It cannot be, the answer cannot possibly be h. Okay, do you all see what I'm saying, guys? The answer cannot possibly be h. H is meaningless. We just have sine of a number that vanishes to 0 squared divided by the number vanishing to 0. Notice in my description there was no mention of h. I just named it h. So Dauda says 1. Safa wants to go into the quantum world and says 0, 1. So what is it? 0, 1? Indeterminate state? Okay, Sophia says 1. Moshe goes with 1. Jeffrey is questioning whether it could be 0. Well, guys, think about it. It's not different than the previous exercise at all. What happens to the number squared? If the number goes to 0, what is the number squared doing? Also going to 0, correct? So what do I want to see here? I want to multiply by h, so I will square this and then put the h that I did the squaring with. And I get, what do I get? I get limit as h goes to 0 of h times sine of h squared divided by h squared. Do you see that, guys? My goal was to, of course, have the thing dividing sine to be the same angle, same quantity. So what do we have now? Now the answer is h goes to 0, so it's 0 multiplied by 1, and the answer is 0. What can you say about this limit then? What do you think about this limit? Unknown, or well, you might use another word, right? So unknown means that, well, I do not know what the limit is, or perhaps you mean something else. Does not exist. Very good, it does not exist. Now why wouldn't it exist? Because this is simply limit as h goes to 0 of 1 over h sine h over h. And what is that approaching, guys? Depending on the approach of h, the 1 over h will approach to either plus or minus infinity multiplied by 1. Sine of h over h approaches, well, right? So it does not exist. Good? All right. So what about this one? Tell me, guys, now what is the limit as x goes to infinity of x multiplying sine 1 over x? What is that? Okay, Nicole. Come on, guys. It's like those superhero movies, right? So you have Clark Kent. He just wears glasses, and suddenly nobody knows who he is. Do you recognize what this thing is? Again, guys, you do not pay attention to A. You don't pay attention to the letter. What's happening? Think about it. All right, Moshe, 1, Jeffrey, 1 over sine, Sophia, that's not, the limit x goes to infinity, so it should not be in the answer. Okay, Moshe, 1, good. Here is what's happening, guys. Look at it carefully. What is, no matter what x is doing, it creates 1 over x going to 0, right? By the fact that by virtue of x getting larger, 1 over x is getting close to 0. Do you agree? And what do we have here? We multiply by x, but to multiply by x is the same as to divide by 1 over x. So this limit is sine 1 over x divided by 1 over x. Yes? Yes? And do you recognize what's happening now? Now it's sine of an angle divided by that same angle, and the angle vanishes to 0. So the answer is 1. Good? What is this, guys? What is this equal to? Very good, Safa. Come on, guys, you should look at it and the reaction is immediate. This thing is yes, Sophia. Zero. Do you agree, guys? Why? Because this is simply the limit as x goes to infinity of cosine of 1 over x minus 1 divided by 1 over x. And you recognize your good old derivative of cosine at 0. Yes? So you look at this thing and you think, oh, this is just the same as minus sine of 0. If you can do it this way, or you just recognize the limit. Up to you. Good? Which is 0. All right. Now, guys, let's try more complicated limits. Slightly more complicated. Let's say, what would you say if I said limit as t goes to 0 of cosine of t minus 1 divided by sine t? What would you say this is equal to? Okay. Very good, Avram. Very good, John and Saf and whoever is saying that the answer is 0. Why is the answer 0? Well, we will see it in quicker way. We will see it more rapidly. But for now, let's see. we see here that it's cosine t minus 1. And if you have a spell checker, you right away think what should go on the denominator. On the denominator, guys, if you have a spell checker and you think the denominator is, well, not quite 1, what is on the denominator? You think, because the spell checker is trying to predict what is the person writing. So if a person is writing this thing, it looks like the person is trying to do what? Exactly, Nicole, t. Why t? Because you try to predict the intention of the person writing it, guys. It looks like the person is trying to do what? Type in the comments. You see, when somebody writes limit as t goes to 0 cosine t minus 1 over, it looks like the person is trying to do what? Very easy question, guys, but very important. Do you see the intention? Because if you see the intention, you can get there by other pathways, by other roads. What's the intention? Take derivative of cosine at 0. Could not have said it better. It looks like somebody is applying the definition of derivative to cosine at the point x equals 0. Do you see that? So that's why it's t, guys. And then, of course, I don't have a t, so I put a t here. They balance. They cancel out. And on the bottom, I put sine t. Now, the first limit is 0. And the second is 1 over 1. Or you can just right away see it's 1. Same thing, same idea. Good? So the answer is 0 times 1. The answer is 0 as you predicted. All right. What about this one, guys? Do you see sine? So x is approaching 1. Let's see if I can write it. What is this limit? Okay, guys, what's this limit? Write to me, please. Thank you, Dauda. Okay, Moshe, it's a funny thing that you have this question mark, right? 0, right? You're saying 0, then say 0. Okay. Very good, Safa, very good, guys. I hope you're getting it. I'm not sure if all of you are, but at least those that are writing seem that they are. So what is the situation here, guys? It's really the situation is that we have limit as x goes to 1 of sine of x minus 1 squared divided by x minus 1, which, guys, I can completely rewrite. Look at it. There's x is just a letter. I can say this is the same as what we already solved before. It's limit as h goes to 0 of sine h squared divided by h. And we already know the answer is 0. You see, I'm free to change the expression because I understand what it's describing and I can describe it in other words, right? If you're driving and you do not know where you're going, you're just following your GPS. Turn left, turn right, go straight ahead, right? You're just following instructions. You just, you make the exact sequence of moves that something is telling you to do. But if you know where you're going, you can freely select your strategy. But you can rewrite it. And that allows you sometimes to get there faster. All right. All right, guys. So here is a question that I would like you to solve. I think you will solve it very fast. So imagine I have limit as theta goes to 0, and here we have sine of 6 theta divided by sine of 3 theta. What's the answer? Okay. Oh, it should look familiar. All right, guys, come on. I want lots of answers, not just 5. I want to see 20 answers. Not 2, come on, guys. It's easy to write it. So here is the answer. The answer is simply 6 divided by 3, which is 2. Here is how some students solve this question. So they see, okay, here we have sine and sine. We can cross them out. And here we have theta and theta, and we cross them out. And we're left with 6 over 3. So the answer is absolutely correct. But it's a very interesting way of being correct. It's like, my analogy is, it's like your grandma will be going up the stairs, fall through all the steps, and just become a young maiden again. Okay, it's that type of correct. In other words, nothing here was right, but the result. Now, why was the result really 6 over 3? Do you understand why it was happening, guys? Here is the, you can solve it algebraically, but you can just think about it, right? So let's try to see what's happening. So theta is going to 0. Sine of 6 theta divided by sine of 3 theta. What happens, guys? The sine, so in this limit, guys, when you see sine h divided by h is nearly 1, what you are, in other words, another way of interpreting this is saying that sine is not changing the angle. Sine is doing nothing to the input when the input is very close to 0. Do you agree? How can sine h over h approach 1? That means numerator and denominator are becoming very, very similar, right? So the only way you see 1 is a number divided by itself. So that means that numerator looks like h, right? In other words, sine applied to the angle looks like the angle. So do you see what's happening here? That means that you can look at it and think, okay, if theta is going to 0, 6 theta is a small angle. So that means that the numerator looks like 6 theta. Sine is essentially not doing anything there. And the denominator looks like 3 theta. That's what's happening. We did not cross the sign. It's just the sign was practically not there. Yes? Now, why did you disappear, guys? I lost, I think, what, 3 people from my screen. Come back. Another way to see the same limit is, of course, to do this, guys. But that's more tedious. So you can write sine of 6 theta, and you want to divide it by 6 theta, right? But if you divide by 6 theta, you then have to multiply by 6 theta. Yes? And yes, on the denominator here, we can see sine of 3 theta. And I would like to see 3 theta here. But if I multiply it by 3 theta, I have to divide by 3 theta. I have to, sorry, divide by 3 theta. And so what happens is that this part is approaching 1. This part is approaching 1. And you're left with 6 theta over 3 theta. Same thing. All right, guys, so let's see what else can we do here. Could you tell me, please, what is the limit as h goes to 0 of tangent x divided by x? Think about it, guys. You can do it. And of course, try to ask yourselves, not over x, sorry, I wrote x here, I meant h. Think about it. What is this limit doing? Why would somebody come up with such a limit? What are they trying to do? That helps you figure out what's the answer. Thank you, Erin. Grant, are you there? Not in spirit. By Zal and you. Okay. Okay. Marin, Mahrin, Afzal. Marin Afzal, Mahrin Afzal. Good. All right, guys, do you remember the question? I mean, I think I've seen only one person answer it. What is the limit as h goes to 0 of tangent h over h? Come on. And for that, tell me, please, somebody writes limit as h goes to 0, tangent h over h. What are they trying to do, really? Could you tell me, please? What is it that they are trying to accomplish? Because if you know that, you can accomplish it a different way altogether. Infinitely many tasks. What, Sophia? What are they trying to accomplish? Exactly, Jeffrey. Exactly. What, guys? Again, I want to see a lot of you answering that most important question. Not what's the answer, but what is somebody trying to gain? Where are they going? Yes? Look at it, guys. Let's see. We work with the definition. Exactly, John. Exactly. You begin to get it, guys. We're not only doing it to make it hard, we're trying to understand how to make it easy. And for that, you have to gauge intention. What is, let's say, an expression? What does the expression suggest? Look at it, guys. Tangent of h. Does it look familiar? This is just limit as h goes to 0 of tangent of 0 plus h minus tangent of 0, right? Tangent of 0 is 0 divided by h. So somebody is taking the derivative of tangent at the particular point 0. Are you seeing it? You all see it, guys? If you get that type of vision, many problems, almost all of the problems in this type of subject become trivial, okay? Because if you open the book and you see what is it, what are those exercises? They're the same exercise, repeated thousands of times. So this is simply the derivative of tangent, which I already figured a different way, where x is 0. And what's the derivative of tangent? That is secant squared of 0. And secant squared of 0 is 1. Do you understand, guys? So the answer is 1, which means tangent also doesn't change much about the angle, right? If the angle is very small, apply tangent to that small angle and you essentially get that same angle. Good? Now, if you understood, guys, tell me please what's limit as x goes to infinity of x times sine of 5 over x. This one, the last one here in this example. This one. Okay. So careful, look at this carefully. Look, what is this thing, guys? Be careful before you conclude. Okay, good. Why is that the situation, guys? Look, you can do it very simply, right? You don't even have to rewrite anything. So you can do it in several ways. One way, guys, is to notice that 5 over x, it's a small number, right? 5 over x is essentially 0. So sine applied to 5 over x. So this expression looks to me like x multiplied by 5 over x, because sine is not doing anything to an angle that's very close to 0. Essentially not doing anything. Good? And then the answer is clearly 5. I can just simply ignore that there is a sign there. That's one way to solve it. Another, if you prefer, is the way we did before. It's just you can divide by 1 over x and just make it sine of an angle divided by itself. Good? Here is another one, maybe one last question. Maybe we'll have time for one more, we'll see. Very quickly, guys, tell me, what is this limit? Try to be very fast with it. I would like to see like cascading answers right away. All right. Go, Darren. Okay, 3 people. It's not cascading, guys. I don't see cascading yet. I only see 3 people. Okay. I hope it's not cascading because you just looked into the comments. Guys, very simple. What's happening? So if theta is becoming small, 5 theta is a small number, and so is 2 theta. They are small numbers, and sine is not changing small numbers. That's the quickest way to figure it out. Yes, sine is not changing a small number. So this is the same as limit where theta goes to 0 of 5 theta times 2 theta. Do you see that I simply ignore that there is a sign? Right? So we have this situation. And then it's very clear that the answer is 10. Good? You understand how we reason it, guys? You understand? We know that we can ignore sine because of this limit. Which means if h is very small, then sine h is essentially h. It's not changing the angle. We observe that, hopefully. All right, guys. So at that, we will end today's lecture. If you want to stay for office hours, then please do if you have questions, or if you want to see that great game, right? We have so many episodes to watch of what, when, where. And one person has already composed 2 questions that I will help translate. Good? It's pretty good questions, actually. I really like them. Something about spaghetti and something about some washing equipment. So take care, guys, if you are not staying. And if you are, well, great. All right, Sophia, have a good one.